Hey everyone, this is Daniel coming up with another long form conversation. And today my guest is Grady Booch. He's a software engineer with more than 50 years of programming experience, and he has been foundational to software engineering, the modern version that we now enjoy. He has worked on critical systems in every conceivable field, and he's made significant contributions with programming languages and type systems and the UML design language and many, many other things. He has authored 7 books, and he's working on 2 more. And he's also working on a documentary called Computing the Human Experience. And we cover a lot in this conversation. We cover good architecture, good thinking principles, AI and the role of the software engineer, how to think software better, communication styles, education, and a lot more. It was a privilege to have him, and I hope you'll enjoy the conversation at least as much as I did. So please enjoy a fascinating conversation with Grady Booch. Grady, thank you so much for making the time. It's an honor to have you.
My pleasure.
All right, so you're known for many things, and you have many significant contributions to the field of software engineering and software architecture. But the thing that I wanted to start with is your documentary project. Can you tell us what that's about and why you decided to make it?
I was on the board of trustees for the Computer History Museum for about a decade. We had just hired our new CEO, a gentleman by the name of John Haller. John had come from Europe working with PBS, and he'd landed a huge deal with the Gates Foundation, which enabled the foundation to actually proceed with building the physical displays that you see now.
Hmm.
So, knowing his background, I asked him, "Hey, John, have you ever considered doing something like Carl Sagan's Cosmos?" He paused and said, "Grady, why don't you be our Carl?" And I paused and said, "I'm no Sagan, but that's an intriguing idea." So I began the journey of exploring that very thing, trying to do a documentary or explore producing a documentary that would examine the intersection of computing and what it meant to be human. I, through the museum, gave 7 or 8 different hour-long lectures just to try out the ideas, and eventually came to the conclusion that there are 12 episodes that need to be told here, ranging from at the very beginning, what do we mean by computational thinking versus scientific thinking, to the last episodes, which address in the presence of computing and the computability of the mind, which is a topic unto itself we can speak of. What does it mean to be human? And we'll look at the journey through all of that. So the idea being, we'll do some history, do some science, but most of all, look at the intersection of computing and humanity. So that's the journey I've been on. We worked with KQED, the PBS station in the Bay Area. They sponsored me for a couple of years, and we did a trailer and a teaser and a treatment, which we pitched to corporate PBS. Their reaction was, "This is precisely the kind of series to which we aspire. Go find a producer." So the last several years, I've been trying to find a producer. COVID slowed things down. At the same time, I'm working on a book. So, one of these days, I hope to have 12 one-hour episodes and a book. That's what I'm working on. In a way, you can think of it as my love letter to computing. It has given so much to me in my life. Now is my time to step back and express what I have found from it. I'm in a curious place because I began my career pre-internet. I got my first email address in 1979, of all things. It was on the ARPANET. And I met many of the foundational folks in computing. Grace Hopper, I didn't meet Turing. He was dead by then, but I met some of the people that worked with Alan Turing. A lot of folks like that. So that's what I'm working on.
Why do you think is it worth preserving this information of all the history of computing in this condensed 12-hour episode, 12 1-hour episode form? And why do you believe is it worth investing so much time and so much effort? If my research is correct, you've been working on this for many years, more than 10,
About a
starting with,
decade now.
yeah.
Yes.
Why is it
Yes.
worth investing so much time to preserve this information in this particular form? What do you think?
An educated population is better able to make decisions about its present and its future. And so my intent is to provide that kind of information. Look today, and I'm sure we'll get into it further in the discussion. Look today at what generative AI has done
Hmm.
to the world. And I had a friend of mine, she's a priest, that reached out to me shortly after the first chat GPT came. And she said, she was very worried, like, what does this mean for us? Is super intelligence going to take us all over? And so, having had a perspective for the history of AI and the kinds of things that John von Neumann, that Turing himself, that others were saying in the early days of AI, they are suspiciously important phrases that I think are relevant today as well. So it's that kind of history that I think helps inform us. And in a way, if you look at it from the perspective of the history and science, you will see the forces that both shape computing and how computing has shaped us as humanity. So, in many ways, this documentary is an exploration of those forces that I hope will help the current populace understand what it means today. I'm trying to do something much like Sagan did that doesn't just disappear after a year because oh my gosh, this new thing was created. But my my study has certainly revealed to me that there's some common threads throughout the history of computing since really the beginnings of computing that still are with us today, and therefore they can represent what the future might bring for us in the coming generations.
Can you give us any examples?
Sure. Um, there's this great book published in the 1940s called Giant Brains,
Hmm.
and it came out around the time we started seeing mainframe computers. This is prior to the IBM 370. And there was a lot of fear in the world that these things were going to take over humanity. There, of course, was the great play RUR, from which we get the term robots, in which those themes were explored. And so I think if you look at computing from an economic perspective, from a legal perspective, from the perspective of what the technology says that we know we can and can't do, I think this helps allay the fears of, oh my God, AIs are going to kill us all. I'm not a P doomer.
Hmm.
I'm anything against that. And so, at least for me, that knowledge of what has happened in the past, like what the fear mongering that happened in the 40s, it's going to happen again and again. If it bleeds, it leads. And so it's certainly catching a lot of press. But by and large, I know that, yes, there are some things that this is touching in terms of our human spirit, but I know that there are limits to what computing can and can't do. So that's one good example.
Okay.
Giant Brains, great book. I forget the author. It's sitting over here on my bookshelf.
All right.
As you can
Well,
see, I'm surrounded by books.
yep. And those books definitely give you enough context to be able to speak with enough authority on the subject. And if anything, you are, if not the only one of the very few people with enough context and with enough authority to be able to do this. And I admire this sort of project. Um,
Well, I write in order to learn. There is so much that I don't know. Um, in my exploration of computing and art, for example, it addresses the issue of what is creativity? What does that really mean? And is it possible to have computational creativity? It led me to understand some of the earliest roots of generative AI, which was, not just the last several years, but there were artists exploring computation as a palette for our art, back in the 50s and 60s. And so it's that knowledge that has helped me understand there are some exciting things today. There's no doubt, and there will still come exciting things. But there's also this steady beat, this relentless rhythm that computing has offered us.
mhm.
And that's what I'm putting my ear toward and trying to illuminate.
How did that look like in the early, in the 50s and 60s with regards to creativity and also with regards to this fear that computers will simply take over the work that seemingly defines us and only us?
Great questions. So let's take an example from art. There is Chowning. Gosh, I'm terrible with last names. He's a gentleman from Stanford who I think it was in the 70s, late 70s or thereabout, that invented the notion of FM synthesis.
Hmm.
And from that was born the classic synthesizer of the era, the Yamaha DX7. And the worry was, oh my gosh, we won't need, artists anymore. We won't need people to play any instruments. Of course, that's not what happened. There was, some legal issues in regards to that. Things like, gosh, if you're going to play on Broadway, you still have to have a certain number of human performers and the like. But what it did is that it opened up a creative palette that brought music in a wider space than we could have ever imagined. And that's, I think, the lesson again and again of what computing has done, that yes, we may fear it, but it opens up opportunities in ways we may have never expected. Let's take a look at art again. There's this delightful artist that I followed, probably 5, 6 years now, Helene, and again, I'm blanking on the name. Um, the way I look at her stuff, she built her own GANs and she trained her own stuff. So,
Hmm.
this is good ethical use because she's not training it on copyrighted things. It's all her own work. And the way I described it once I really got into her work was it's a lot like Michelangelo. He was renowned in many ways, but one of the things he did is he ground his own pigments. That's exactly what she is doing. She
Hmm.
has this incredible artistic ability, and her pigments are the GANs she has created that gives her this incredible palette upon which she can do things that speak to us as humans. So that's one of the examples that comes to mind.
Nice. GANs, the generative adversarial networks.
Yeah, generative adversarial network. Really, this is work that became before the diffusion stuff and
Hmm.
before which fuels a lot of the current things like Midjourney and the like.
Yep.
And even before that, there was a gentleman in the '60s. He had a system called Aaron. Of course, the '60s and '70s were a time in AI of not large language models, but knowledge systems, which
Hmm.
were rule-based systems. They followed the symbolic systems that Newell and Simon and others developed during the '40s and '50s. And people like Ed Feigenbaum pioneered the ideas of knowledge-based systems, which are if then else kind of things. That's kind of like what this gentleman did for a system called Aaron. And there's a great display at the Computer History Museum on it. But it's really amazing art that can speak to you. And so, we see these kinds of developments and over again where new algorithms are created that create new opportunities for us to express our feelings in new palettes.
This is very interesting. This is fascinating. So I'm already seeing two themes in your documentary. One is the fear that the computers might take over what makes us human, and two, the ability to express ourselves with the help of computers. Is there any other such theme that permeates the thread of your documentary?
There's another one, and this relates to the danger of computing as a tool for subjugation. I don't fear the rise of superintelligence. I do fear the rise of the rapacious, non-empathetic individuals and companies who seek to use computing as a means of power.
Hmm.
And we see this again and again. This is the theme of RUR, the play upon robotics. We see it even if you go back to Greek mythology. One of the earliest examples of AI was a uh, a clay figure called Talos, and I think this is in the Odyssey.
Hmm.
But Talos was a clay figure that walked around Cyprus and he would hurl stones at anybody that came too close. He was powered by some magic elixir put into his heels. The Greeks had a real obsession with heels, but that's
Hmm.
another topic unto itself. But it points out that there's something within us as humans in which we seek to become gods. And
Hmm.
that's, I think, where we're resonating with current AI because there are some and Sam at OpenAI and others who I think are really believe that we are on the path of creating our gods. Of course, the problem he has, and this is the theme I deal with here, you have a few individuals who think they're the chosen ones. They know the answer and trust us in this process. Of course, I don't trust them in
Mm-hmm.
this process, and they don't have a solution to it. And it's incredible hubris and hypocrisy on Sam's part, where he says, "Gosh, we worry about all these things, but we're going to build it anyway." And you've seen this again and again in the history of computing, and that's why I'm not freaking out over it, because I have seen it again, and I have great confidence in the resilience of the human spirit to endure.
Well, I share your optimism, of course, with not nearly enough context and understanding and knowledge as you have, but it's really great to have you share some of that here. I just
Well,
read.
keep in mind, sorry to interrupt, but keep in mind that I have a perspective. Computing is a huge thing, and the tagline I have is the story of computing is the story of humanity, and there are many many stories. I'm telling one story, and it comes from the experience I've had inside the industry, but also as somebody who, cares about what it means to be human. So it's a story. You've got a story too, and you should tell it.
Well, I hope that I'll gather and as I grow in my career, I will gather enough context to be able to form my own story with the degree of precision and um, uh, nuance. I think that's is the word as you have, and I wanted to touch upon this towards the end of the
Sure.
conversation. But now that we brought that up, one thing that I admire a lot about you as a key figure in this industry is your ability to express yourself and communicate to such a precise and nuanced degree that I hope to be 10% of the communicator you are, even though I am a teacher and this is one of my goals to be able to express complex ideas with enough clarity, preciseness, and nuance. Um, and I wanted to ask about this particular skill. Did you happen to grow it in any way with intention, or did that just occur along the way? How did that skill grow?
That's a great question, and thank you. I'm deeply flattered by your observations. Uh, I try to communicate well. There are three people whom I've never met that have been a big influence upon me in that particular topic, and not necessarily in any order of importance. There's, of course, Carl Sagan, who was
Hmm.
just a tremendous educator, and his ability to weave science with deep philosophical ideas. I aspire to his degree of fluency. The second is Richard Feynman, and I especially resonate with Dr. Feynman's notion that if you can't explain a topic to like a 5-year old or some normal person off the street, then you probably don't understand it yourself.
Hmm.
And indeed, this is something I've struggled with. I'm so deep in the technology. Um, One of the things I've had to develop over the years is to make sure that I do express these things that may have some very deep, complicated elements to them, but in a way they're understandable. And if I don't do that, then I have utterly failed. And the third person who's very much influenced my thinking is Joseph Campbell,
Hmm.
in his work with the Hero of a Thousand Faces, uh, the transformation of myths through time. These folks, and I think especially what I learned from him is just stepping back and opening my aperture to the exquisite beauty and wonder of what it means to be human, and and the rituals we humans have produced, the history we've gone through. These are all things that just thrill me, and I'm hoping from what I learned from him to express that same kind of joy to the people to whom I speak. And as for the nuance, I mean, my gosh, this is complicated stuff we're dealing with here. And so I try to be careful in what I say, because there are very few absolutes. And this bothers me by again what Sam and Elon and many others say because they view the world in a black and white. For me, no, the world is not that. It is full of nuance, and that's part of the wonder of being human.
Did you happen to practice this sort of communication in any way and gather feedback and um, exercise this sort of muscle to be able to speak and communicate clearly? I mean, even in the conversation that we're having right now with questions that you haven't seen, you seem to speak with a degree of fluency and preciseness that I've seen you speak in your TED Talk. And TED Talks are are famous for being so intensely rehearsed. So I'm wondering, is there any degree of practice to this sort of muscle that you have done?
I'll answer that question, but let me go back to TED Talks because I gave a TED Talk and I absolutely infuriated the TED people because I was trying to do some things out of the box. There's a particular rhythm and pace and style and storytelling
Hmm.
within TED. And I annoyed them by I would for my practices, I memorized everything. I didn't write everything down. Most of the stuff I just sort of do off the cuff, and that'll come back to my story in the moment. And so in all my rehearsals, it was always the same thing. Of course, when I was on stage, I feed off of the audience.
Hmm.
And so, much to their dismay, I let that come in and let the audience adapt with what I was doing. So, where did that come from? Um, I grew up in Amarillo, Texas, a small town of some 100 plus people, a classic Cold War town. Amarillo was in the panhandle of Texas. It was known mostly for oil and gas. And during the Cold War, into World War II, the beginning of Cold War, where the Russians were the bad guys, Amarillo Air Force Base was established because it was a place where Strategic Air Command aircraft could come
Hmm.
there. It was also the place where we had the Pantex plant, still exists. And the Pantex plant is the one place in all the United States in which the triggers for all of our nuclear weapons are assembled and disassembled. So it's
Mm.
got this curious rural character, but also, really lots of governmental things going on as well, too. My dad, of all things, was a sheriff. So it's like, wow. I remember coming back from the Air Force Academy once on some break. The academy is a pretty brutal place, and he thought my hair was too long from that even, but that's another story. Anyway, in high school, I took some debate classes, and what really helped me were some spontaneous lecture classes as well too, where you'd be given a topic, you had 5 minutes, and you had to talk on it right then. So I
Hmm.
think that's when I began to develop my skills when I was what 14, 15. I still remember my debate instructor and my speech instructor. I thank them constantly for that because that's where the foundation was laid.
That's amazing. And it's really great that um, you became aware of this skill and got and put yourself in positions to practice that by giving talks and conferences. And I actually wanted to ask about that. Are you still do you still go to tech conferences at all?
I do most of them. I do virtually. I haven't traveled for a while because I've I get lots and lots of requests, but I mostly turn them down because writing requires focus, and I live here in Maui. So if I were to go to Europe, that's like 3 days for me to get there and give a talk and then back. So that's a major commitment of my time. But here on Maui, I can focus on writing, and it's that peace and solitude and focus that have enabled me to do the things that I'm doing here. So yeah, I'll do it. And like things like this, this is easy for me because I don't have to get on an airplane
Hmm.
and I don't have to do any preparation for it. But I'm very open to doing those kinds of things.
And we all appreciate you for it. Um, do you have a process for writing and for delivering a good conference talk?
So let's separate those because there's a different process from giving a conference talk versus writing a book. Two very different things. And there's a third one, which is, writing a short form article. For about 10 years, I wrote a column for IEEE software. The
Mm-hmm.
first one was on architecture, and then I switched it over to on computing. I did
Mm-hmm.
what 30, 40, 50 of those kinds of things. So let's take each of those. For a lecture at a conference of some sort, those turn out to be easy for me because in most cases, I'm simply talking about the things that I'm currently working on. So I will, I do very little research on them because it's mostly in my head.
Mm-hmm.
I'll start out with a basic storyboard and then I'll do pictures. In fact, if you look at most of my slides, there's very little text on them. It's
Yep.
mostly a large picture, and then I talk about them. And I never rehearse. I just sort of do it because those pictures remind me of what I need to say. Preparing for an hour-long lecture, I don't know, I might spend 30 minutes, something like that. And I don't mean to shortchange my audience, but it's like, this is what's in my head. So you're getting raw, undistilled Grady. For the articles, it's not unlike that, especially with the things with IEEE software. They gave me degrees of freedom to write what I wanted to. So in most cases, I would write something that I was currently researching, and I have this sort of portfolio of notes and things like that. So I'd go through it and say, what do I want to say here? What's triggered me? And I'd write those down, and the story would sort of form itself. Now, the book I'm writing on currently, very, very different beast, because you can see I've got all these books around me.
Mm-hmm.
And I'm surrounded by these because there is so much I know I don't know. Let's take, for example, the book on computing and science.
Mm-hmm.
So, I mean, gosh, there's an obvious connection between computing and science,
Yep.
but gee, one of the rabbit holes I went down was, where did we start with the use of computing for meteorological and climate studies? Turns out it was all the way back to John von Neumann. And there is this really interesting history of how we grew from just those ideas, which actually fueled the creation of supercomputers, which also helped in, of all things, the Test Ban Treaty during the Reagan days, which is an interesting connection with computing and conflict, to even today, where we're looking at less of the symbolic kinds of systems for meteorological studies to ones that are more neural based. So in those cases, there's a lot that I know I don't know, which is why I've surrounded myself with books like this. Especially for this particular book, I set up my own website, and over the last multiple years, I've read, hundreds, if not thousands of articles. I've not read every word of all these books here, but read certainly most of the important pieces of each of them. And along the way, I take notes, which I put on this website and divide it out chapter by chapter. So when I go and write a chapter, then what I'll do is I'll go back to those notes. There are probably maybe 10,000 notes I have per chapter. I will print out the interesting ones, and then I'll cut them up and I'll sit in the middle of the floor and I begin to sort them. And the story sort of follows itself from there.
Is this
That's how it is.
nice? Is this book technical in nature, so for a technical audience, or for more of a layperson audience?
It is. So I'm writing two books right now. There's one book for the technical audience, which is a book about software architecture. And we can go into that detail later.
Mm-hmm.
But the primary book I'm working on, the computing effort, is really for the general public, or as I like to describe it, it is for the intellectually curious public
Mm-hmm.
who wish to know about the roots of computing and where it might head. So, your mother and father might be interested in it. And I'm trying to write it at a level where it wouldn't overwhelm them,
Mm-hmm.
but it could perhaps tell them, why is my son doing this crazy stuff? But
Mm-hmm.
hopefully it will speak to them. The other thing I have to realize is that computing is a global topic.
Yep.
There are stories that cover China and India and South America and Africa. And I'm trying to be sensitive to those voices because I don't want to end up with something that's just, old dead white guy stuff out of Silicon Valley. If anything, I've learned in my research, the story of computing is so much richer than the verbiage coming out of Silicon Valley right now. And I want to honor the wonder and beauty of that.
That's so nice to hear. This is tied into the documentary, right? So this is
Yes.
another facet of the
Yeah,
documentary.
exactly. I wanted to do it like Sagan did, where he did the book at the same time the documentary was done.
Hmm.
Haven't found the right producer for it. Just haven't fit. I've worked with, and you can probably put this on the podcast. Ron Howard and Brian Grazer, worked with them a bit, and COVID kind of slowed that down. Ridley Scott's team as well too of Blade Runner. COVID kind of slowed that down as well too. But I'm talking to some really interesting producers at the moment. Of course, the challenge is that the world of broadcasting is vastly different than it was when I started this, because you had PBS back then, and thanks to the orange cockwomble, that's actually a term I can use because it's a phrase from the UK, cockwomble. It's nothing obscene. He's trying to get rid of funding of those kinds of things. So, and streaming, the rise of streaming. So, maybe this is on Amazon or Apple or Netflix or something like that. I don't know, but there's a story waiting to be told, and I don't know what the right distribution form of it is, but it'll come.
Understood. Uh, how would you gauge success of this project? What would it take for this project to be successful in your eyes?
Great question. My goodness, that's interesting. Well, the first success would be I finished the book and we actually do the 12 hours.
Yeah.
And, if I do just that, then I will be happy. If you read it, if some other friends read it, then I will have achieved what I wanted.
Hmm.
I'm hoping, thousands, if not more than that, would watch it. I think in all of my books, I've written what, seven. I think by latest count, I've sold like 1.5 million books, something crazy like that. So, I'm hoping I'd see numbers like that. But, in many ways, I'm doing this for me because it's very satisfying and I'm learning some things in the process. And, if others enjoy from what I've done, then all the better.
Sign me up. I'm definitely
Yeah.
gonna.
I don't need external validation for what I'm doing.
Yep. That's well. Okay. If anything, if I may offer another compliment, it's yet another reason for appreciation, because when you're doing this out of a core need or a core desire for yourself, that's that's going to produce even better work, because you're not going to necessarily form the work on the basis of the audience. You're forming the basis of the work on you, which is how I've aspired to do my own work. So I can definitely resonate. So
I
yes.
have a particular journey through computing, and it's a very unique one
Hmm.
because I was there at the cusp of the move from the first golden age of software engineering to the current one. And I've seen the change of computing over my lifetime. And there aren't a lot of souls that can do that have had the breadth in what I've done. I've also had the incredible opportunity to work in projects across so many different domains, not just your classic web-centric systems of global elastic scale, but things like, medical systems and weapon systems and transportation systems. And it's pretty fun. It's been a lot of fun, and I think what I'm doing now is, I just it's just the sheer joy of being able to explore these things again in depth.
Very cool.
I'm having a lot of fun doing this.
Well, this conversation is probably going to be listened to by mostly programmers, so software engineers. So it would be amiss if I didn't ask about software architecture and software engineering as it's changed over the
Sure,
years. Um,
software architecture. It's a good idea.
yeah. So one thing that I was curious about is that there has been a recent conversation going online in many different shapes and forms
Sure.
about the Gang of Four design patterns, that they're taking a lot of heat for being very overly rigid or too much ceremony, and taking a lot of heat these days. Do you think that's warranted, or is
Yes,
there more nuance to it?
it is. It's warranted, and it's the same thing is true with even the UML. That if you take it in very dogmatic ways, then it loses the purpose of it. I'll talk about patterns in a moment, but let's go back to the UML. I mean, the words I had that I wrote at the very opening of the standard still hold true today. It's a language meant for reasoning about systems.
Hmm.
And most of the diagrams you create from it, you want to throw away because its value is the scaffolding and understanding and reasoning about the decisions you make. You know of my definition of architecture. All architecture is design, but not all design is architecture.
Hmm.
Architecture represents the set of significant design decisions that shape the form and function of a system, where significant is measured by cost of change. Now, I struggled with that definition for a long time because there were many other definitions. The Software Engineering Institute, in particular, had one, and they were dealing with structure and shape and things like that. I love those guys dearly, but that's not what my experience was.
Hmm.
That architecture was all about decisions, and the shape you ended up with was the consequence of those decisions. And so I wanted to focus upon the process of that decision making. The same thing, therefore, is true with regards to patterns. All complex systems are full of patterns. There's I'm deeply influenced by the work from the Santa Fe Institute on complexity, and there's just a whole body of literature about the structure of complex systems. I had the wonderful opportunity of writing a paper with George Ellis. George is the gentleman, the astronomer, who worked with Stephen Hawking,
Hmm.
and they wrote the classic book, The Large Scale Structure of the Universe, something like that. And so George Ellis got wind of my stuff. And we talk about an amazing connection because here I'm a computing guy and here's an astronomer kind of guy. And he noticed that I was interested in patterns. And he also has this view that if you look at astrophysics and much of science, we grow that field based upon our discovery of patterns. But those patterns should never be dogmatic because the universe, nature is subtle and wonderful and obscure. That there are many patterns, but there are not sharp edges to those patterns. And I think that lesson can be applied and should be applied to the Gang of Four. They are the smells. We know we can look at a system, we see these patterns, but to be dogmatic about them leads us to systems that are far too brittle.
Okay. Now, if you say if you are talking about code smells and having a little bit of leeway into the patterns themselves, that leads into a subject that I was very interested for quite a while, which is, um, for the lack of a better term, good taste in how you design
Yes.
your system. And I was curious to understand how one can get that sort of skill, the sort of good taste, because a programmer like me, when I read a book like this, I go like, oh, this works for here. This is a piece of puzzle that works here. If the software that I'm designing fits this sort of shape, I can apply this pattern. It's like a sticker. Just use that. But as you say, there are many situations in which you don't need to apply that particular pattern exactly as it is, or verbatim, or with those exact particular details, but then you leave some space off. And I'm wondering what I don't even know how to phrase this question, but how can somebody learn this sort of skill and this sort of nuance, this sort of um, granularity to be able to say, oh, this pattern works maybe 80%, but here are the rough edges that we can smoothen out in this way. How can one learn this skill?
Well, that's a great question, and I think there are two elements to that in my experience. The first is having experience across the domains of computing will help you not get in a rut. I
Hmm.
mean, a lot of the books you read about architecture these days, they're nice and fun, but by and large, they focus upon a particular architectural style. It would
Hmm.
be like saying, "Oh, I want to learn about civil architecture, and the only book I give them is about brutalist architecture
Hmm.
or that particular thing." But it works. It's okay, and there are certain patterns that one can find with web-centric systems of global elastic scale, and these things have been codified in places like Amazon's AWS, which is both good and bad because, I mean, the economics of AWS have sort of forced us into particular patterns that are hard to get out of. And when you choose a piece of it, it's the Roach Motel strategy, in which once you're in, it's really hard to get out. And so you're stuck with all these other consequences of those kinds of things. But if you look outside your domain and say, "Hey, I'm building this web system. Wouldn't it be interesting to learn what the architecture of Alpha Fold was?" Or
Hmm.
let's look at the architecture of I don't know, the London Underground.
Hmm.
So being exposed to those things, I think, will help any individual get out of their box and say there are alternative modalities of thinking, and engineers have solved these problems with a completely different set of problems in which there are many different forces. But wow, that inspires me to think within this particular case, maybe I should try this idea that I learned from over here. It's that kind of cross fertilization that I think is something that really great engineers have. That's one of the two elements. The other element is, I think, a recognition and an understanding of some meta patterns, and that is the following set of things. It is a desire to build systems that have a good separation of concerns,
Hmm.
that you have layers of abstraction, and all systems. All of software engineering is one of largely of rising levels of abstraction. And then lastly, simplicity. You take those three things plus patterns. Those are meta lessons that I think guide me whenever I see a situation and say, well, what would help me optimize those meta things? And that helps me decide what patterns might fit into place.
Is there any way to accelerate that skill acquisition? I feel that so throughout the conversations that I've had so far, um, and by my own thinking over the last uh, year or two, while thinking about this particular subject, it feels to me that this skill of good taste can only be acquired through lots of exposure, lots of experience, and time is a very crucial factor. So you cannot really short circuit your way into a very nuanced, high quality skill of this sort. And the because one of my main jobs is to produce learning material for the things that I'm particularly good at. One of my areas of focus is to how to accelerate that particular skill acquisition. So my question to you is, can this sort of skill be accelerated in any way?
Yes, I think it can be. And let me give you an analogy. To become a great writer, you do a lot of reading,
Hmm.
and it helps to read outside of your domain because you will learn rhythms and patterns and textures of color of language that you can then use to influence your particular style, and you'll find your own voice along the way. And so I would recommend one way to accelerate for an individual developer is go read lots of other code, and it's available to you. I mean, you can go find the source code for uh, Mac Paint, Apple's Mac Paint. It
Hmm.
exists. You can find it on the Computer History Museum. And it's actually a very beautiful piece of software. Don Knuth, who once remarked, it's probably the most beautiful piece of software he has seen. So it doesn't take long to look at it and find it online. And I think what you'll learn is that in the presence of constraints that those developers had, what is the kind of structure they ended up with? And you'll learn two things. First is, wow, it's a really visible structure, that it's not difficult to see the essence of the architecture there because it's just in the code itself. And the second is, it's probably very different than the kinds of things one write. The code is the truth, but it's not the whole
Hmm.
truth. And so reading things around that code, the comments and such as to how they ended up with that is another great way to learn. Here's a great example. I had an opportunity to work with to interview the two architects of Photoshop. One of the gentlemen was one of the original architects. The other was brought on later. At Adobe, they had two of them. They split their responsibilities because one was responsible for the Mac code base, the other for the PC code base. It was really fun to see the two of them. But they walked me through the architectural changes that took place over the years.
Hmm.
And that is an interesting story into itself, because you'll find that external forces required Adobe to change the architecture of Photoshop 4, 5, 6 times. But at its essence, some of the original abstractions are still there and endure. And so, if you want to learn how to write lots of great code, read the code of others. Go read some of Linus's kernel code. It's beautiful stuff.
What makes beautiful code to you?
Great question. Beautiful code flows, it resonates, it tells a story, it is clear, it is simple, it is not obscure. There's such pressure, I think, among many individuals, especially those using Copilot-like tools, to write the tightest, smallest code they might write. But the problem is it's going to be impossible for somebody to follow on and understand it. And more likely, people will throw it away because it is so difficult to understand. And so, take a look at what Knuth has talked about with is it Knuth? Yes, it's Knuth, and his ideas of literate programming,
Mhm.
which was the predecessor to clear programming. It just basically says, you want to write in a manner that you expect other people are going to read it, people who don't necessarily have the full context.
Is a variety of programming languages a factor uh, in this breadth of being able to read and understand other people's code? So, the
Absolutely.
okay,
Yeah,
um,
there's an interesting culture that develops too. I remember writing some Lisp programs that became public, and some of the original Lisp authors came to me and said, "Well, that's really interesting and it's true and it works, but man, that's not the way we from the inside of Lisp would write it." And they told me how. So every language sort of develops its own idioms. In fact, important word there, because within the hierarchy of systems, you have idioms, you have patterns, and you have architectural styles, which is an example of a meta concept, because
mhm,
each of those are kinds of patterns, just at different levels of locality. Idioms are what you see at the language level. This is the way I write an iterator. This is the way I write, recursion. And
mhm.
it's different for every language. And it's generally part of the culture of the language itself. Patterns are a level up, and then architectural styles are something completely different. And
Oh,
if you want to learn more about that, go study the stuff of Dr. Mary Shaw in her classic
mhm.
book, Software Architecture. Mary's just a delightful woman.
I've heard you recommend this book by Mary Shaw. Is there any other book or any other material that you would recommend somebody study software architecture? Because ever since uh, software architecture started, lots of material have popped up, lots of books. Um, what would you recommend a regular programmer, a good programmer, go study in order to get and internalize the good foundations for software architecture and elevate themselves to a level of a system architect?
They need to read the book that I'm writing, but it's not done yet. That indeed is the book I'm trying to write. And in that book, you've seen some of my lectures on software architecture and the like. In addition to just capturing those lessons learned, I'm trying to document the architecture of about a dozen different systems, to do exactly what I described here, to
Hmm.
expose to people the very different architectural styles that exist within the world. Because not everything, again, is a web-centric system of global architectural scale. They're all different kinds of things. But in the meantime, yeah, there's some books. I mean, what do I recommend in that space? Martin Fowler, of course, has some
Hmm.
great books on architectural patterns. I like his work. Um, Bob Martin has written some good things in that space as well too. Uh, I'm staring at my bookshelf over this way. I have to admit that my head right now is in the midst of the computing thing, so no immediate title comes off. But
Hmm.
I think somewhere I put in some website the several hundred plus books I have on architecture right now.
Awesome. We're going to leave links in the description. What are
Sure.
some systems or some domains where the the software architecture of that particular system you found particularly fascinating? Do any examples come to mind?
Yes, that's a great question. Let me think for a moment. Hmm. Remarkably, I'm first question you've asked me in which I'm drawing a complete and utter blank. What has surprised me the most? Well, I'm thinking about some flight control systems of certain missiles, and just the degree of 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 math within them, the deep stuff that you see that is so different than a web-centric system in which you're, pushing text or images around. But there are some systems of some really enormously hairy, incredibly complicated math at their core. And it just astounds me that these things work.
Mm.
And I'm delighted that they do, because I still fly on airplanes, and I use cars with anti-lock braking systems.
Yep.
And so seeing these whispers of model checking and formal verification within them, that just still blows me away, that we have the ability to build systems that operate in the real world, with its, filled with ambiguities and gaps and contradictions and noise, and this stuff still works. And so I think the answer to your question is, there are systems like that that touch the real world, that just, I'm just amazed at the beauty of their complexity. And it also tells me just how darn complex the real world is.
Right. I'm just beginning to discover. Um,
And
you
by the way, this is why when people talk about, oh, robots are going to take all of our jobs in 1 or 2 years, like, man, you haven't really dealt with the real world very much. We're a long way from that. The real world is harsh.
Yep. I wanted to ask about formal methods because you just
Yes.
mentioned that. Where do formal methods matter? And because there is a discussion in the programming languages space, I'm a particular fan of Scala and functional programming, and Scala has a particularly powerful type system where a lot of things are checked by the compiler, and you want to make sure that things are correct before they run. Many people in this community believe that it's such that's an indictment on software engineering that we are still at the stage where the only way to learn whether a program is correct is to run it. And they very much advocate for formal methods and formal verification and stuff. Where are these important, and are there situations in which formal methods are really not?
Another set of great questions. And you introduced the issues of typing as well. In my experience over the decades, and I look at the number of systems which I've been engaged with, formal methods, pop up in a fraction of a percent of the systems that I encounter. And in most cases, it appears in those places where human lives are at stake,
Hmm.
where a failure means people die. And it's in those circumstances where you can't fail that formal methods are so important. So it goes back to the economics and the moral issues. We want to apply these kinds of techniques in those cases where the cost of failure is so high. Because remember that formal methods work really well for certain things, but they don't deal with the problems of the reality of the external world. So I might build a formal system that tells me, or I might use a formal system that says, hey, I've got this thing that, helps me drive this car. And functionally, it may be wonderful and perfect, but the problem is not so much and I feel confident that formal methods have helped me there. But the problem is, I can't account for every edge case,
Hmm.
and so systems that are functionally proven, you have to recognize there are limits upon what they can do. No functional system that I have ever encountered, when no formal system of reasoning or model checking system deals with things like, oh my gosh, a cosmic ray has just flipped the bit on this
Hmm.
particular ROM. This is outside the scope of most systems of formal methods. Most formal methods don't deal with time and space kinds of things of the real world. So from the very beginnings, we know our mathematical abilities are limited. We could do it theoretically, but the systems are so complex, there aren't enough, seconds in the life of the universe to do that. Now, typing is a different issue because strong typing, and I'm a great proponent of it, having been involved with the creation of Ada back in the day, which was a strongly typed language. Strong typing helps you in gluing pieces together, but it doesn't necessarily help you with the functional aspects, the operational aspects of a system. There's a whole different set of mathematics you need to do there. So scale is great, typing is great. I think it's wonderful, but even so, that only addresses a piece of the hard parts of the system. So short answer is to your question, yeah, if the cost of failure is high, then there probably is a role for formal methods. But even so, we know that formal methods have a limitation to them. I mean, one of the great uses I've seen for formal methods is Microsoft used it to validate device drivers for various forms of Windows. Great stuff, because you have a complete functional specification. You knew when things were right or not, and so functional methods or formal methods were absolutely perfect for that. But there are very few cases where that is true.
Do you see the JavaScripts and the Pythons warranted to the degree that we see them currently? So there there is a lot of complaint about the quality of the code being pushed to production, and a lot of that criticism is directed at the tools and the languages that are used to push that, because Python and JavaScript in particular are relatively easy to pick up. And so it's very easy to push faulty code that hasn't been checked and so on and so forth. Dynamic typing also plays a role. And so a lot of criticism is directed at those languages and those tools. And I'm wondering, to what degree do you think those tools and that style of writing and pushing code is legitimate?
Visual Basic had the same problem in that Visual Basic back in the day was a language that was transformative. It meant that people who were not just full-time programmers could all of a sudden build full-fledged applications under Windows, and
Hmm.
you would see entire businesses being built around it. Problem is that it was very fragile, and so the code ended up being very disposable. I think the same thing is true with JavaScript and Python, that it's easy to build simple things. But the problem is, once you've written a line of code, all of a sudden becomes legacy. And you're building up this weight of code that's difficult to change over time. So, for lightweight things, I use Python's my primary language right now. It's great because I throw away most of the stuff I do. It's not like I have a
Hmm.
million people using what I'm creating here, and that's fine. So it's fine for me because it's very malleable. But as I start building systems again, like air traffic control systems or pacemakers or things like that, then you want to apply a little bit more discipline, and maybe those aren't the right choice of languages for it. I would not recommend using Python for a nuclear weapon, for example. That would be a really profoundly bad idea.
Yep. Um, and that ties into the AI bit, that LLMs are now generating a lot of code, and most of that code is generated in the most popular languages, and the most popular languages being JavaScript and Python. The LLMs are going to generate even more of that. And I wanted to ask if you could speak to that. Is there a danger, not necessarily from the point of view of, because we've talked about this a little bit, and we might expand further on the topic of replacement of software engineers and whatever. But I wanted to ask you about the quality of the code pushed by LLMs in these languages that could become dangerous if applied to the wrong systems. Could you speak to the quality of code being pushed by LLMs?
So there have been a number of really formal studies that suggest that LLMs produce code that has far more security holes than ones developed by humans, that they produce code that is is very fragile, that breaks in strange ways. So it's hard to use, and so there's a seductive problem in that if I'm a developer that's never used this particular API or something, then my gosh, these tools, Cursor or GoPilot or Copilot or whatever, any number from which you could choose, they accelerate that. And so for
Mm-hmm.
a novice who knows nothing about these things, it's a great way to build prototypes very, very quickly.
Mm-hmm.
And in the hands of somebody like Andrew, who of course developed the idea of vibe programming, in the hands of an expert, he's someone who knows when the code is utterly wrong.
Mm-hmm.
So he's in a very good place where he can discriminate. The problem is this group in the middle, the people who are trying to build systems that endure and using code along the way. I fear for that I think most of these kinds of systems, I worry about the degree of bullshit that they produce in our code, and it's it's a clear and present problem. And I don't know how we change that. To be very honest,
Is there any
it
way,
worries.
uh, do you have any recommendations for, okay, the problem of having people uh, intentionally add discipline to the code that they produce, be it with Copilot or their own code, is enough of a hard topic. But at the individual developer, do you have any tips for how to add discipline and how to add guardrails and maybe systems, not necessarily technological systems, but mental systems for them to avoid producing stupid code with real consequences?
I think some developers will never have the desire to do that because they're so happily churning out code for which they have no responsibility once it's out there. And so there is no incentive, either economic or scientific or moral for that matter, that would incentivize them to provide that discipline. And I think LLMs in particular have enabled the growth of that particular segment of the industry. So I worry about that.
Yeah, so it seems to
Uh,
be a skin in the game problem.
yeah, you're right. How much skin in the game do they have? Yes. And especially with the job hopping we see in so many places in the Valley, it's like, I'm going to write this code and, I'm not going to be working with this company after I vest. So why should I care?
Mm.
That's a real problem. In the end, capitalism wins out, that these companies they're going to, they eventually will die. Truth and reality are harsh, and they'll eventually
Hmm.
come to grips with that kind of reality. But right now, we're in a funny place, I think, in the industry where it's so easy to produce things that are of such poor quality because there's so much money chasing these companies right now. I'm I'm thinking right now of a particular project. I can't mention the name of the company.
Hmm.
Let's just say that they're trying to apply LLMs to a particular customer support problem. And to begin with, they're already starting off wrong because there's great FOMO in this company. Oh my gosh, our competitors are using it. Let's sprinkle some AI pixie dust into what we're doing. And they failed to step back and say, what are we trying to do for our end users and customers? But instead throwing the AI into it to see what happens and see what sticks. The problem is some of them succeed, but most of them will fail. And I think time will tell. We're in a curious phase right now where there's a lot of energy and excitement and wonder, but I've seen this happen before. And what's the phrase from Battlestar Galactica? All of this has happened before, and all this will happen again. And the same is true here.
Do you think there's an overhype with the current AI wave?
Absolutely. There's tremendous overhype at the moment. And not just overhype, but just too much money chasing it. And, Microsoft and Google and OpenAI, problem is they're cramming it down our throats. It's impossible to even do the simplest kind of things without saying, by the way, here's this new AI feature you can have with it. Well, I don't want that feature, but you're forcing me to use it. And that's annoying. The great thing about science and the thing about computing is that over time, truth wins out and it becomes a very, homostasis kicks in and will eventually find the right standard. Right now, the weather vane's flapping all over the place, but we'll get there.
It's probably a bit of search happening until we get to that direction.
Absolutely.
Yeah.
Yeah. I mean, a good analogy is think back to the very early days of laptops when they were first created. I mean, the idea of a laptop came from Alan Kay and his idea of the Dynabook. And when the form factor of the laptop came out, you saw all sorts of experimentation with different ports and different ways of, using cursors and the like and little displays and the like. But ultimately, we settled down to a pretty standard form, and a lot of the laptops look very much the same as one another. And that's because we went through this phase of experimentation, lots of wild, strange ideas. But eventually, the marketplace decided, and science decided, and time decided. The same thing is going to happen with AI, I believe.
Are LLMs from the point of view of a programmer? So you've said this not only in this conversation, but in other conversations as well, that software has generally moved towards higher levels of abstraction. Are and I have an opinion on this, but I'm gonna ask you first. Are LLMs another layer of abstraction, or are they something else?
I would say there's something else because they represent the pendulum swinging between discrete, deterministic, symbolic systems to systems that are more statistical in nature. I mean, that's what LLMs are. They're a statistical beast. They allow us to build these multidimensional networks and give us ways to search through them. That's, from an architectural perspective, that's what they are. Um, Hang on, I'm going to bookmark this notion because I'm going to go down a rabbit hole. And this goes back to AlphaGo, which is another great example of that.
Hmm.
Not an LLM, but a neural system. When AlphaGo beat the human players, one of the gentlemen, I think from Korea, he was visibly shaken by this, and
Hmm.
he said, "Oh my gosh, I've seen the hand of God in this one." I like to think of it this way: that LLMs in that particular architecture have allow us to create a multidimensional space. And in the case of things like protein folding or chess games and the like, or just producing coherent conversation, they're all related in the sense that tradition and experience and human factors have led us down particular paths within this multidimensional landscape. The thing that LLMs do statistically is they are not burdened by the history and such that have led us to these paths. So when AlphaGo made these remarkable moves, it's because they explored hills and valleys that we had not seen as humans because our past had led us away from them.
Hmm.
But statistically, they were there. We simply had not shined a light on them. And that's where I think a lot of the interest comes from LLMs because they produce astonishingly coherent output. The problem, of course, is they're not grounded in reality. That if you've often heard me say, our large language models, transformer-based architectures, are architecturally incapable of building systems of truth because they have no basis of truth within them. And any truth you might see for them is accidental and only statistically interesting. Yet they are truthy enough that they fool a lot of people to the point where, well, we've already seen it
Hmm.
diagnosably. People are going down the path of using LLMs and replacing their loved ones with it. They're finding God in the process. This is Eliza on steroids.
This is a very interesting take because LLMs being uh, statistic, they have no notion of truth, and I was curious to uh, gain your perspective on how humans have at least the perception that we can discover the truth. I've had conversations with a friend of mine who is deeply in the LLM space. He's a PhD now, and we were talking about conscience, and I asked this question that sparked a very long form, multi episode conversation between the two of us in our meetings as to how we can discover the truth differently than the AIs and currently the LLM species of it. So I was wondering about your perspective on this ability to discover truth. How is a human fundamentally different in this search?
A great question. Humans are also impacted by a context that LLMs do not have. We have desires, we have subjective experiences, we have goals, we have sense of love and beauty, and all these emotions that an LLM does not have.
Hmm.
And I believe they shape us in ways individually and culturally because of what society is shaped around it in a particular place that provide a context that an LLM is simply not able to encompass. Remember also that we humans are embodied.
Hmm.
And so we live in that complex world of noise and gaps and these kinds of things. Whereas if I'm an LLM, the only world I've seen is what's been presented to me largely through text and through pictures, which are very self selected, mostly coming from the internet and the like. So they see a fraction of the observable space of what it means to be human. So I think that's one thing that distinguishes us.
Yeah, because I was wondering, and this is completely outside the questions that I prepared for this conversation, but I find this particularly fascinating, and I've been pondering this topic for a while because we search for truth because we set truth as an objective, and there are measures by which we can gauge whether something is true. For example, through either mathematics or formal proof, or through science by invalidation and filtering things that are not true. Um, and I'm wondering to what degree could an LLM or an AI of the next generation species be presented with an objective function like that and call it a truth-seeking AI? Because as I'm hearing people like Sam Altman and Elon Musk uh, talk about this rise of AGI and their whatever they're developing, I tend to agree with you uh, with respect to the criticism of the hubris and the uh, hypocrisy of creating things that we don't really understand, that we might think that we do, and uh, also think about this argument of, oh, we're simply we're simply building a truth-seeking AI. And given this context, I mean, this is a long-winded question. To what degree could an AI, given your experience, be presented with an objective function that is measurable in similar ways to ourselves and call it a truth-seeking AI?
A comment, I should say. And the fact that we're going down this path is what just delights me about the whole topic of computing, because notice how we are eventually led to these deep philosophical questions
Mm-hmm.
of what it means to be human. So that's one of the great, I think, chilling outcomes of computing itself. You may be surprised to know that my studies And for the last 6 or so years, I've been studying with a set of neuroscientists to understand the architecture of the brain. I've come to the conclusion that the mind is computable.
Mm-hmm.
Now, Roger Penrose would disagree with me, but that's a topic for a completely different podcast. I think Roger is wrong in that regard. That's okay. But it then says, well, gee, maybe the things that we do are human are indeed computable, but we're probably generations away from that because LLMs are certainly not the right architecture to do that. There's this great play by Lily Tomlin and her wife. I think it's titled The Search for Signs of Intelligent Life in the Universe.
Hmm.
And in it, Lily plays the character in which she says, reality is just a shared hallucination.
Hmm.
And I think there's great truth in that, that what we see as humans, I mean, we have, as in humanity, we have a particular view upon what the cosmos is and what it is not. As Sagan has said, we are the way that the universe can know itself. But even so, we are looking at it through the lens of our own humanity. And there probably is some truth within that that we as a species have. And this is not to say that there aren't truths outside of our species. To go down another rabbit hole, I do a lot of work with a number of cetacean researchers,
Mm-hmm.
researchers in humpback whales. And I'll swear, if you ever get to a blue whale, largest creature, mammal ever to walk the earth, well, swim the earth, and look them in the eye, there's this concept of the I thou, which Martin Buber speaks of, in which you look into the eye of another and you see the presence of another soul, the idea of having a theory of mind of others. We know that something else is going on there. So there probably is some, deep shared truth among anything that's sentient.
Mm-hmm.
But then if we go back to my notion that the mind is indeed computable, can LLMs get us there? Well, the problem with LLMs is because they are purely statistical. Consider what they're trained on. They're trained upon the corpus of things we have fed them that are only a fraction of humanity.
Mm-hmm.
They don't cover the vast things that are in books or oral histories of the like. So, and furthermore, they're relatively new things. They're mostly things that have been on the web for the last few decades. And we know that the human experience is far grander than that. So LLMs statistically have maybe captured a fraction of what is possible, a fraction of a fraction. And even so, can it find truth within it? But what is truth? Well, gosh, now we're getting to some deeply philosophical things. And I think the answer there is a truth is something that whose reality can be tested in its falseness.
Mm-hmm.
And LLMs don't, of course, this is the nature of science, that we have hypotheses and
Mm-hmm.
we can come up with ways that test their validity or not. And that's how science progresses.
Mm-hmm.
LLMs don't do that because they're just simply saying, statistically, I've got this multidimensional space. You've given me this huge context, which is basically a vector into it. And hey, it's close, but that's not necessarily the only truth. It just so happens statistically what happens if I point in there, but not objectively because it's not measured to the outside world. And that's where the embodiment thing comes into place. Our truth comes from our embodiment as conscious beings in the world. LLMs don't have that. So we're in many ways, we as humans are speaking very different languages than the LLMs. Their truth is not the same truth as what we as humans have.
Yep.
Nor do I think they ever will be.
This is so interesting, and we could go on and on about the subject because it's I mean, not just podcasts, but many books and a lot of
Oh yes.
ink has been spilled on the subject, and for very good reason. I wanted to ask about your optimism in the face of these really seismic changes in the technology space, because a lot of programmers I see they're scared by this new technology, by AIs of whatever generation of whatever species we might end up producing, that it's going to take a lot of our work as software engineers and stuff. And I've seen you on multiple occasions express a lot of optimism and excitement about this particular field, about software engineering. So it's by any stretch of the imagination, probably the most exciting time in software engineering. And I was curious to understand why or how that feeling came to be in the face of reasons for being um, fearful of these new technologies.
Well, let me talk about the optimism and then I'll go to the issue of fear. So, um, in many ways, my career grew up from the transition from assembly language to higher order programming languages. So I saw
Hmm.
the rise of compilers and the like. And the rise of higher order languages put a lot of individual developers in certain jobs, whole classes of jobs.
Hmm.
They didn't exist anymore. You don't need flowchart people. You don't need key punch folks.
Yep.
And so the rise of things like compilers all of a sudden made computation accessible to a vastly larger number of folks. And that's why I say that the history of computing, history of software engineering is one of rising levels of abstraction. The same thing is happening here. So it destroys certain classes of jobs, but it creates opportunities for completely new classes of people that simply would have not existed before. I've got a friend who is a school teacher, and she's been using LLMs to take a story, in Hawaii in particular, and recast that story to different age groups, to elementary school, to junior high, to high school. That's great. So all of a sudden, she now has a tool that allows her to take the essence of an idea and express it across a wider set of folks much faster than she could ever have done. And that's great. But remember, there's a human in the loop. She's the one who is able to assess the truthfulness of that. And furthermore, these are all stories, so there's no objective truth in them,
Hmm.
but there is subjectiveness. And with the human in the middle of it, it's great. So this is a classic example of where I think LLMs can provide some real useful value. The danger, of course, is when I start using LLMs not in objective ways, or sorry, not in subjective ways, but in objective ways, like, gosh, I'm going to read your resume and decide whether or not I'll even consider you for an interview. Well, we know they're
Hmm.
full of biases. We know that there's no accountability within them. And so there's incredible danger that we can now automate racism and misogyny and bias and all these kinds of things and dismiss it because we as humans uh, remove ourselves from the process of responsibility.
Hmm.
That's, I believe, where the danger lies in an existential way. There's a clear and present danger associated with the use of LLMs because we see them. It's not, I think it's going to, kill humanity. I don't worry about that. My P doom, as they say, is asymptotically approaching zero. So I don't get worried about those things, but it's the clear and present things where I see it introducing biases and this upon people today. And how do we counter that? Well, laws and shining light upon it, like what you and I are doing here, to express to the politicians and the public that there are clear and present dangers to them. That's how we deal with it. Last thing I'll mention, back to my optimism. Um, there's a great book titled 1000, which is basically look what was the world like at the change of that first millennium. If you think about it, this was a time of science wasn't really
Hmm.
big. We didn't even really understand science then. Lots of myth and these things fueled the world, and there was concerns, real concerns, that at the change of that millennium, that it was representing the end of the world. Of course, it didn't happen. We lived through that. Go back even further, in some millions of years ago, um, geology or archaeologists and anthropologists will tell us there was a period of time that maybe 18,000 of our proto-humans existed, and we now, all 8 billion of us, rose from that 18 or so thousand that persisted. So this leads me to suggest that from the year 1000 to the Middle Ages and all that to those times, we as a human species have a remarkable ability to adapt and to change and to thrive. And we've done it for over the millennia, and I have no reason to believe that we won't continue to do that kind of thing. And that, by the way, is what distinguishes us in many ways from the AIs that I see being created, because they are not so adaptable and resilient. They're still so very brittle and so very narrow in what they can do.
I think this is as good a place to start wrapping the conversation because
Sure.
on the optimism side, there's never been a more exciting and full of opportunities time to create good software for to create more beauty and more utility for people. And I
And I would also add that software is an incredible lever, that the ability for a single person in the, wherever they might be, um, they can make incredible changes. There's a dear gentleman, I've met him only once virtually, Tunde, oh, and his last name escapes me. He's a chess grandmaster who really grew up from some of the slums in Africa, and he's done this marvelous mission of bringing chess to kids. The phrase he uses, great things can come from small places.
mhm.
This is especially true of software, that the levers we have with software are astonishing in their ability to what they can do.
I will take that, and I also intend to propagate this because one of my other projects is teaching kids to code, and
Oh, great.
I see kids running with ideas to such a degree that it astonishes me. And when I was a kid, I wish I had these opportunities. So I'm very very excited for them, and I would like to help them however I can. So
Yeah,
this is a nice mission to have, I would say. Uh,
it is.
Grady, it's been an honor to have you. Thank you so much. I want to be respectful of your time. I have a million of other questions, but you are very generous with your time, and I wanted to say thank you for your work. And for everybody else, we're going to leave links to the video. And until next time, thank you for listening. Grady, it's been a pleasure.
My
Thank you.
pleasure. Aloha.